Take a look at the fluid animation in this sequence. Generating complex movement with this level of detail used to require high-tier model subscriptions. Today, a platform called Kling AI produces these results reliably. We are going to map out the exact workflow to generate up to 15 seconds of motion-controlled video. We will build these sequences from either a text prompt or a single photograph, entirely for free. To follow along, you only need two things. First, an active email account to access the platform. Second, if you want to animate a specific person, you need a high-resolution, unblurred portrait image of them. This generative sequence replaces the need for high-cost animation suites and manual character rigging with a simple set of instructions and a reference image. Inside the Kling AI dashboard, head to the primary video generation menu. The first step is to explicitly select the version 3.2 model architecture from the drop-down list to ensure you are using their most capable engine. Next, we configure the foundational output settings. Set your baseline resolution to 720p. Then, match the aspect ratio to your distribution platform. Select the wide format for a standard YouTube video or the vertical format for a short or reel. This diagram highlights the platform's primary advantage, duration control. Standard free models typically cap generation at 5 seconds, but Kling expands that window up to 15 seconds. To utilize this, click the timeline parameter and drag it to the far right edge. Securing a continuous 15-second generation window provides the physical timeline required to let a complex narrative action play out completely. Let's establish the baseline workflow by directing our attention to the text input field. A structural prompt requires specific environmental and action details. For example, we describe an individual standing in a dark studio, actively manipulating floating holographic screens. Once you hit generate, there is a short latency period. The engine needs a few seconds to process text variables and render the physical environment. Here is the final output. The engine accurately translated the textual instructions into precise environmental mechanics and lighting. Text-only inputs work very well for generating broad concepts and environments. However, they lack the pinpoint precision required if you need a character's specific facial identity to remain consistent across multiple generations. This split comparison illustrates the advanced image-to-video workflow. Uploading a crisp, high-data reference image processes a clean structural wave. If you input a low-fidelity or blurry image, structural integrity breaks down, corrupting motion data and leading to a distorted output. To safely execute an image-based animation, we rely on a strict 3-part prompt formula. The first variable is the subject directive. You must explicitly command the AI to designate the uploaded image as the primary focal subject. The second variable defines the atmospheric conditions. This is where you specify the exact lighting style, the mood of the scene, and any specific camera movement you want the engine to simulate. The third and mandatory control variable is the identity lock. You must append the exact phrase, maintain exact facial identity of the reference image. If you struggle to format these variables manually, you can use the platform's Enhance Prompt function. This tool autonomously restructures basic text into our advanced formula before sending it to the generation engine. Injecting that specific phrase overrides the AI's tendency to morph facial features during movement. It forces biometric consistency across the entire 15-second timeline. Once your clip is generated, you have options for post-production. The Modify protocol allows you to retroactively alter a prompt. Take an existing clip and tell the system to change the final physical action, like instructing the character to sit down at the end. You also have access to an upscale workflow. Clicking this mathematically increases the final pixel density of your output asset, resulting in a sharper image. Because this tool provides a free daily generation limit, you need to manage your request rate. Enforce deliberate time gaps between your generation requests to avoid triggering the free tier rate restrictions. When you are satisfied with the final result, click the download button to save the finalized video file directly to your local hardware. Leveraging these post-generation refinement tools allows you to turn a raw AI output into a professional-grade distributable asset without paying premium software costs. You have now successfully engineered a high-fidelity, dynamic video sequence starting entirely from a single static input. The next technique to explore is advanced motion. This allows you to extract complex physical movements, like a viral social media dance, and map that exact motion data onto your newly generated character. You can also integrate this visual workflow with conversational models like Gemini Omni. This pairing allows you to create fully voiced AI avatars that sync with your custom animations. Mastering the structural generation we covered today is the required first step before you advance to cross-platform motion cloning and fully autonomous character simulation.